I'll tell you after.
Okay, so you can pick any cell. I'm just gonna pick that one, and I'll say call it temperature, and then I can merge these cells. Give me a second. Okay, merge and center. Did you see where I did that? I clicked that part there. It may look different in different versions of Excel, but I merged and centered it so that temperature is there over the 3 rows, columns. What I'll do actually, I'll make it 4 because some of you have 4 temperatures. So I'll merge it to there. Oops. There we go. So the first temperature, and we know temperature, the units are degrees Celsius. If you want to add that in Excel, you have to go to Insert, Symbols. You see on the complete right there, Symbols. I look for the degrees symbol, and that's the one, it's already on it. And I hit Insert, close that. Degrees Celsius, put that in brackets. Very important you put the correct units. Okay. I'm just going to pick random temperatures. That's 20, 40, 60, and 80. Okay, that's what's going to go on my x-axis, because that's what I'm changing. Then I have some trials. So I'll call trials here. And I've got my first trial, second trial, third trial. Everyone did 3 trials. Remember that?
Yeah.
Then over here, we were measuring the time taken to dissolve. So I don't think I didn't add this on your guys' graph, remember last time? But you're just gonna have to add it. You call it time taken to dissolve the Alka-Seltzer or the antacid. Okay, it'll look like that. Do you see how I increased the size of that? Double clicked on that corner here. Alright, so let's say I put in my values. I'm gonna bold this stuff here, make that in bold, all the temperature stuff in bold as well. So the values that go there are the results you got. Does anyone have their results table open? Well, I'll just use the actual results. Okay, these are Jared's results I'm going to use. Okay, so for 20 degrees, he got 25.59. That was the first trial. Then the second trial, he got 25. No, he got 30. And then for the third trial, he got 21.43. For 40 degrees, first trial, he got 22.4, then 28, then 22. Then for 60 degrees, he got 22.5, 24, and 22. Then for 80 degrees, got 24.35, 19, 24.5. Okay, now from here, look here. From here we have to calculate the mean. Now that I've got the data, so I put all the values in there. I want to calculate this thing called average. Now to do this, look carefully. I use a formula. So I go on the cell there, and I go at the top, I say equals average. Then I open my bracket, and I say I want the average of these first 3 trials. And then I close my bracket, press enter. You see it's calculated the average for me there? Then I scroll all the way like that, and you would have calculated the average for those for the other three temperatures too. Now, another thing I want you to do is standard deviation. And I'll show you why we need that. Standard deviation. Now, we don't need to go through the maths. We're in science, so we're just going to use the statistics functions we've got here. And so what we'll do is, we go again to the cell that I want, hit equals, standard deviation. I'll use that function there, open the bracket, and I want the standard deviation between these three values. What this standard deviation means is how accurate is your results, right? If you get a high number like that 4, that means your results are not so accurate. Something went wrong in one of those trials. The more trials you do, the more accurate your results get. Because think about it, if you do it over and over and over again, you're going to get closer to the result. Does that make sense? Yeah. So let me drag this and see what we get the standard deviation for the other ones. Do you see at 60 degrees, it's 1.04? That means the trials we did for 60 degrees, or the experiment at 60 degrees was very accurate, was good. And now let's try plotting our graph. So when we plot our graph, I want temperature to be on my x-axis. So right now I highlight that until 80. Then I want to plot that against my mean, my average of those trials. So I hold Control. If you're using a Mac, you'll be holding Command, and then you drag those as well. Then I go to insert the scatter chart there, and I want it with the line. And that's what it shows me. So yeah, that makes sense. That actually makes sense. So look, when the temperature was low, it took a long time to dissolve. Can you see that? And then when the temperature is high, at 80 degrees, the tablet dissolved really quickly. Now, time taken to dissolve the antacid is in what? Seconds. So I need to come here, call it seconds. S will do. Okay, pay attention. Alright, this is what I've got. Now I want to add some trials here. I want to add some stuff here. Okay, so my graph makes sense. At low temperatures, the time taken to dissolve is much longer compared to when the temperature is high. You can see it from the graph there. Now, let me add some things. I need titles, axes, all these things. Now, if you're using Windows, there's the plus sign there, and you can add things. If you're using Mac, it will be in data or review. But just ask me if you're using a Mac and I'll show you where it is. So you can add axis titles, all right? I want you to add those. And with error bars, right, I'll show you that later. Let's make these axis titles. So that is time taken to dissolve, antacid, and that is in seconds. So I call it seconds. This bottom one is temperature. So I come here, I call temperature. There we go. Chart title, you could call it the average time taken to dissolve antacid over a range of temperatures. Now I've got a beautiful title there.
So do you have to write like the degrees?
Oh yeah, good one. Yes, I do. I'll just copy it from here. So I'll copy the degrees Celsius from here, and I'll chuck it here. Okay, now I want to add some standard error stuff. Now this is a good graph. If you've got this enough, that's fantastic. Now there is a small part in the report that talks about reliability and validity. So what you want to do is those standard deviations we calculated. Remember I said low standard deviation, that means accuracy. High standard deviation, that means not so accurate. Now we want to represent those in the graph. So I press that plus symbol, I go error bars, but now I go to more options. I want to customize my error bars. So I'll go there and I'll say specify value, and positive error bar is the top one, and I want to just select all of these three like that, and the negative one is the same values just on the negative side. So I select those values again and I hit OK. Now you see I get those error bars on my graph. Let me close this. Can you see those error bars? Those say how accurate my data is. Alright, so this one here is not so accurate. As you can see, it's small. This one's accurate because it's so small. These ones, not very accurate. Alright, so what we want to do is I want to get rid of those horizontal error bars. So I can go there. And then I can just say 0. So we get rid of those ones and we just have the vertical error bars, and it looks like that. Does that make sense? So which one's the most accurate reading when we did temperature? Which temperature gave us the most accurate results? 60. Well done. Okay, one more thing. You could do percentage change, and that's up to you. So you could come here and say percentage change. I'll put it up over here. Percentage change. And that's how we calculate that. Listen up. That's how we calculate percentage change. Is if we want to do the percentage change between 20 and 80, we can put a formula. So percentage change, I'll say between, I should write it, between 20 and 80 degrees Celsius. Okay, now over here I'll go back to my function, I hit equals. Now look here, this one can be confusing. You hit equals, and then I take this 20 minus, I should put my brackets, so I'll put brackets first. I'll say 20 minus 24.35 divide by the smaller number, which is 24.35, multiplied by 100. And you get 5%. 3 brackets, that's even better. So we'll put another bracket there. After the divide there. And like that, that makes our formula the same. We still get that answer, okay? But it's good to use brackets. If you're not sure, always add brackets like that. That's perfect. Now, I don't have to repeat the same formula for everyone. I can just click that and drag it over there. And I can get a value for everything. Yeah. So it was a loss. There was something off. And then you can, now when you've got these values, you can talk about them in your results, in your discussion. In your discussion, this is mainly what you talk about. Is there something wrong? I think the values were different. These values that we put were different. I think yours was 30 and 15. That's why it was 100% change. So check your values. Any questions? Make sure you get yourself a nice graph.